First, the footings. We dug down 45 centimeters, which is 18 inches, and laid concrete footings. Fortunately, William had sent a big template of the base with the oven positioned on it, and that had the exact measurements for the floor, the dome, and the arch. All of this was on a big piece of plastic, so we were able to check all the measurements exactly. Now, once the footings had cured, and we allowed a couple of days to do that, remember, there's going to be a lot of weight on those footings. The shipping weight on the oven alone was 600 kilos, about 1,400 pounds. Plus, there will be a lot of support concrete, about a ton of sand surrounding the oven for insulation. Of course, you will use all of the techniques of professional building. Plumb lines and levels, all of that. This is not a job for an amateur. We decided to use brick for the foundation. Now, you can use cinder blocks or you can use Besa blocks if you want, concrete blocks, but we chose to use bricks to match in with the house. A full foundation was built up to the correct height. Now, you'll notice that mine is pretty high, but remember, it has to be done to the right height in the dining room. And the ground outside the house did slope down a bit, so that's why it's tall. We chose exactly where we wanted the opening to be in the dining room. And Bob, the specialist builder who did the installation, hit that spot perfectly. He wasn't even a millimeter out. After the brick foundation layer was up and had cured, we did a second wall, a double wall of brick. Remember, the incredible amount of weight means that you will need the strength for support. You'll also see that there's a big strong center pillar to add support to the concrete slab that will be put on top of the brick foundation. To install the concrete slab, there are several options. You could use Hebel block slabs. And if you do, you'll want to do a double layer and fix them together. But we felt Hebel was not the way to go, and Bob created a foundation for the poured concrete slab by putting steel beam supports across the top of the foundation. Now, they are, of course, exactly at the same height of the pillar support. Corrugated iron formed the base on top of the steel and concrete support, and then a 100 millimeter, 4-inch concrete slab with reinforcing mesh was poured in. You'll also notice that there is expansion foam all the way around the concrete to allow for heat expansion. Now, this is still not the base that the oven will sit on, but we chose to make it very smooth and even anyway. A couple of days of curing, and Bob was ready to build the foundation for the oven to sit on. A ring was drawn on the concrete, depicting the floor of the oven. Remembering, the distances must be accounted for to make the oven mouth fit through the hole in the wall. If you're doing this as an outdoor installation, the measurements will be, of course, a lot simpler to calculate. But if you're doing it for inside the house, really do take care to get it right. Bob the builder then carefully did the measurements for the archway that is the front of the oven and has the flue opening. This measurement was made keeping in mind the exact positioning in relation to the floor and how far the flue arch and door piece will be pushed through the exterior wall of the house. Okay, now around the circle drawn as the position for the floor of the oven, a ring of bricks was mortared in place. At this point, you'll start using special Refrax mortar. Normal concrete will not take the heat that will be developed from the oven. From this point upwards in the installation is where the heat will be felt later on. Notice that plenty of mortar between the bricks in the circle has been used. This helps to avoid heat dissipation and to make the oven more efficient. Then, inside the circle, a layer of Refrax mortar, about 2 inches or so thick, about 5 centimeters, to form the insulated base that the oven floor will sit on. Again, this is an insulating layer that will increase efficiency. This 5 centimeters or so was done in 2 separate applications. It's very important to get this right. It's an important insulating layer. While the circle of bricks lined with the Refrax mortar was curing, the job of cutting through the outside brick wall of the house was tackled. Now remember, the position had been marked, but now it's double checked, and using a brick cutting circle grinder, the opening was cut. After a bit of refining, the opening was exactly the right size, and the door and the flue archway was put into place. You'll notice the steel reinforcing lintel that was installed to provide support over the opening. After at least a day of curing, you'll be nearly ready to start assembling the oven dome itself. Into the circle that is lined with Refrax mortar, put in about 4 or 5 inches of dry, washed river sand. However, much sand is needed in order to fill up the ring that is the foundation. Now, it's vital that this sand is truly dry, dry, dry. Any moisture will cause shifting in the floor and will create a problem later on if it's uneven. The sand goes in and is tamped down really well. Then the floor is laid onto the top of the sand. Notice that the floor fits exactly within the circle of bricks that is holding the sand. Remember, we had the benefit of the template which made the installation very, very easy to get the measurements exact. So there is the concrete slab, the brick ring, Refrax mortar lining, dry sand, and then the floor. In this particular oven, there are 5 floor pieces. Refrax mortar is used to join the pieces together. It's important to make that mortar even and flat so that your shovel or your pizza peel won't hit any joins between the floor pieces. Then, the front piece of the oven that has the flue, the oven opening, and the door on it is placed on top of the floor. And then, each piece of the puzzle is assembled. Each piece sits on top of the ring of bricks, and you will leave a gap of about 10 millimeters between the floor and the wall of the oven dome. Here it is from the inside. Remember to allow for expansion by allowing that gap between the oven and the dome itself. This is important.